Hello guys, today we'll be doing LeetCode question 1603, design parking system. It's an easy question. The question is, design a parking system for a parking lot. The parking lot has three kinds of parking spaces, big, medium and small, with a fixed number of slots for each size. Implement the parking system class. Parking system takes values of integer, which is big, integer value medium, integer value small, initializes the object of the parking system class. The number of slots for each parking space are given as part of the constructor. In Boolean, addCar is a function which takes an input type of integer car type and checks whether there is a parking space of car type for the car that wants to get into the parking lot. Car type can be of three kinds, big, medium or small, which are represented by 1, 2 and 3 respectively. A car can only park in a parking space of its car type. If there is no space available, return false, else park the car in that space and return true. So example 1. We initiate the parking class, we add car. So we initiate the parking class with one big space, one medium space, 0 small spaces. We add the car of we had a big car, returns true. We had a medium car, returns true. We had a small car, returns false, as there's no full spaces. We had a large car again, returns false, as we've already taken a large space. So the explanation is here. Create a parking system with parking spaces, one big, one medium, 0 small. We add a car to the parking system of a big size, return true, because there is a 1 available slot for a big car. Parking system addCar 2, return true because there is 1 available slot for a medium car. Parking system addCar 3, return false because there is no available slots for a small car. Parking system addCar 1, return false because there is no available slots for a big car. It's already occupied. So the way we do this is fairly simple. We'll just create variables for this class representing each car type, each parking space type, so big type, medium type and small type, and we set it to the input fields here. So the parameters here, Then when we add a car, we check if there's a space available, then we decrement it, and every time we check if there is a space. If there isn't, we return false. If there is, we decrement it and return true. So I'll show you how to do it here. Let's say we've got a parking system, and again we push one big car, one medium car. Let's make them more clearer. One big car, one medium car, and 0 small cars. Now we call to add a car of type medium. So we add a big car. So now we know that space is taken. So we remove it. We have 0 cars. Now we add car of type medium. So we know that we have 1 space left for medium. So then we take that out and return 0 because that space is now taken. Now we add car of type small. And we look at small. There's 0 spaces, and we can't get less than 0. We can't park a car with no spaces, so then we return false for that one. Whereas these ones here would return true and true. So let me show you how we would implement this. So to set a variable for a class, we would set this dot big is equal to big. This dot medium is equal to medium. And this dot small is equal to small. So now by setting the variables as this, we can reference them in the actual function. So what we'll do is we'll check, so if car type, so we know that 1 is equal to big, so if car type is equal to 1 and this dot big is bigger than 0, then we know we can park a big car. So we set this dot big, or we decrement it by -1, because now the spot is taken, and then we return true. I'll do the same for medium. We check if the car type, we can do else if to make it easier. So else if the car type is a medium type, so it's equal to 2, and there is a space available, so this dot medium is more than 0, sorry. And again we decrement this dot medium and we return true. And we do the same, so else we know that car type is small, so we have to check that, actually not else, so else if car type is a small car, so it's equal to 3, and there is a small space available, so this dot medium is bigger than 0, then we decrement this dot small as well. So not this dot medium, this dot small here. So if there is a small space available, then we decrement this dot small, and then we return true. Else, we know that there's no space available for that car type, so we have to return false. Now if we run, see this passes, let's submit. As you can see, this is one of the faster methods. This has a time complexity of, for this one, of 0.1, as we just set the variables to each value in the parameters. Each value is a parameter. And for each function here, we just decrement and return true, that's 0.1. Here again, we decrement, return true, and decrement, return true. So all of these functions here are of 0.1. We just check the car type and return either true or false. Thanks for watching.